Hello, and thanks for watching our machine design presentation. We are Nathan Anderson, Trevor Christensen, Sterling Larson, and Ryan Melander, and we are pleased to present our final design project. To start off, we were assigned to model a simple jack for agricultural applications. For this project, we decided that the jack would be put in tension, as seen in the diagram on the left. In other words, the jack would lift and release from above rather than from below. We also designed for a max static loading of 2,000 pounds, a buckling factor of safety of at least 2, high fatigue strength, as this jack will be used frequently, and a flexible reach of at least 6 inches. We went the extra mile and decided to double this distance to 12 inches, as you can see on the figure to the right.
To begin the methods section, we started out by using a MATLAB model to find the forces in each member, both the screw and the outer members in the frame. From the plot shown at the bottom right, it is evident that the highest forces occur in each member at the lowest position of the jack. Those forces steadily lower as the jack is raised from 5.5 inches to 11.5 inches, giving a total displacement of 6 inches. In the numbered diagram here, you can see some different points of failure that we consider to be the most key points of failure. Buckling failure and axial failure in the screw were a major point of focus, as well as tear out in the frame or the outer member. And finally, bearing stress and shear stress were of a large concern in the pins, especially the pins at that meet the frame and the screw.
Into the results section, we first calculated our stresses using hand calculations, and then we plotted those stresses into MATLAB as a function of how high the lift has been lifted. And as you can see here, at 0 height, meaning it hasn't been lifted yet, the maximum stress occurs for all these kinds of stress factors. And then we went and plotted a safety factor graph so we can see how close we were to failure with each one of these types of stresses. And as you can see here, the lowest safety factor that we have is 2.52. That's for the buckling on the screw. And that was important. We wanted to make sure the buckling had at least a safety factor of 2, so we had to design to sustain that. But all other safety factors are fairly large and not close to failure.
Before we reached our final system setup, we did have to do several iterations in ANSYS. Our first iteration, we found that the crossbar buckled before full load was even reached. So we had to slowly increase the diameter in ANSYS until we found that the diameter of 3/4 of an inch of that crossbar would give us a safety factor over 2 at 2.5. So we were happy with that. And we were also happy that because we increased the diameter of that crossbar, it also increased the holes in the pins. However, the safety factor on the bearing stress of the pin was still high at 7.3, so that meant that it was a success there. However, there were several shortcomings. There was no stoppage for max height on our system, so somebody could unscrew it all the way and make it a very unstable system. So in order to fix that, we'd have to put some sort of stopper. The crossbar isn't attached to both pins, so that means if our system was put into compression, then the crossbar would detach completely from the system and collapse. So in future generations, we would have to find some way to attach that crossbar to the back pin. There was also no handle to twist the crossbar, so it would be pretty difficult to extend our jack, so we'd have to add that in future generations. Our material cost overall was $76, which is pretty cheap, so we figured that it was a cheap enough system for this. Also, our system is desirable because it's easy to manufacture. There were only 3 parts that had to be machined after they were ordered from McMaster-Carr. And it's also symmetric, so that means somebody could put it upside down, it wouldn't break. We figured that this has meant that our system was successful, and thank you for watching.